Title of the first section today is Simplified, exponents. In this section, we'll simplify expressions that have exponents. First problem is 2 to the power 3 or 2 to the third power. 2 to the third power means the number 2 times itself 3 times. So we'll have 2 times 2 times 2. Multiplying this out, 2 times 2 would be 4, times 2 more would be 8. So 2 to the third power is equal to 8. Second question, 4 to the second power, or 4 squared. Again, we'll take the number 4 and multiply by itself 2 times. So we'll have 4 times 4. Multiplying that out, we'll have 16. Next question, in parentheses, -2 to the fourth power. We'll have -2 times itself 4 times. So -2 times -2 times -2 times -2. Multiplying this out, -2 times -2 would be +4. And -2 times -2 would also be +4. Multiplying 4 times 4, we'll have the answer of +16. So -2 to the fourth power would be 16. Last question for the section, -5 to the second power. In this question, we have -5 to the second power. The exponent only goes to the number 5, not to the negative. In the previous problem, the exponent went to the entire parentheses -2, but in this problem, the negative will stay outside, and we'll have 5 squared, which would be 5 times 5. If you remember PEMDAS, we'll do exponents first, and then multiply by the negative. So in this case, we'll do the exponent, which is multiplying by 5, and then add the negative on after. So 5 times 5 would be 25, and putting the negative on there, we'll have -25. So if the negative is inside the parentheses, we'll multiply by negative numbers. If there is no parentheses, just the negative stays outside, and you'll multiply the positive numbers. Title of the last section today is 0 and negative exponents. In this section, we'll solve questions that have 0 exponents and also have negative exponents. Two definitions for this section. X to the 0 power, where x can be any number or any variable. This will always equal 1. So any number or any variable to the 0 power equals 1. And the second definition, x to the -1 power. Again, x could be any number or any variable. Negative exponents will make a fraction and take the reciprocal of the number or variable. In this case, x, we'll put on the bottom of the fraction, and the exponent will become a +1. If there's no other numbers in the question, we'll put a 1 on the top. So x to the -1 is equal to 1 over x. First question for the section, 10 to the 0 power. 10 to the 0 power, looking back at the definition, any number, any variable to the 0 power equals 1. So 10 to the 0 power would equal 1. Second question, negative 16 to the 0 power. Again, any number to the 0 power equals 1. The negative, though, does not go with the exponent. The 0 only goes with the number. If there's no parentheses, the negative would stay with your answer, and 16 to the 0 power would be 1. So the answer to this question would be negative 1. Next problem, 5 to the negative 1 power. Anytime you have a negative exponent, we can make a fraction. And if this number is on top of the original fraction or there is no fraction, we can put the 5 on the bottom, and the negative exponent, negative 1, changes to positive 1. If there's no other numbers for the numerator, we can add a 1. So we'll have 1 over 5 to the first power, which is the same as 1 over 5, or the fraction 1/5. Next question is 6 to the negative 2 power. Like the negative 1 exponent, a negative exponent, negative 2, means we'll have a fraction for the answer. If it's 6 to the negative 2, we'll put the 6 on the bottom of the fraction. And instead of negative 2, we'll rewrite this as positive 2. So anytime you have a negative exponent, you can take the reciprocal, and then the exponent changes from negative to positive. And again, if there's no number or no variables on top, we can add a 1. So our final answer would be 1 over 6 to the second power would be 6 times 6. So we'll have 1 over 36 for the answer. And last question for the section, negative 3 to the negative third power. Again, negative exponents means we'll have a fraction. The number 3 we can write on bottom of the fraction. Keep in mind the negative outside does not go with the exponent, so just the 3 would move to the bottom, and the negative 3 exponent we can change to a positive 3. The negative that we have left over, we can leave that on top, making it negative 1. And our final answer, negative 1, would stay the same. 3 to the third power would be 3 times 3 times 3, which would be 27. So our final answer is negative 1 over 27. Title of the first section today is Simplify, Exponents. First question is 3a b to the 0 power. Simplifying this, the 3, if it does not have an exponent, would stay the same. The a also does not have an exponent, so that would stay the same. And b to the 0, if you remember from previous lessons, anything to the 0 power is equal to 1. So the 0 exponent only goes to the b, it does not go to the a or the 3. And we have 3a times 1, so our final answer would just be 3a. Second question is 5x to the negative 4 power. Simplifying again, the 5 does not have an exponent, so the 5 would stay the same. From the previous section, anytime you have negative exponents, we can make a fraction for our answer. And if we have a negative exponent, we can put this term on the bottom of the fraction. So x will go to the denominator, and instead of negative 4, we'll have positive 4 for the exponent. So negative exponents we can take the reciprocal of and change. X to the 4th cannot be simplified, so our final answer is 5 over x to the 4th. Next question, 1 over x to the negative 7 power. Like the previous question, we have a negative exponent. This time the negative exponent is already on the bottom of the fraction. If we have a negative exponent in the denominator or bottom of the fraction, we can move that to the top of the fraction. So x to the negative 7 would change, moving to the top of the fraction, x to the positive 7. If you want to, you can put it over 1, or the final answer would just be x to the 7th. And next question, x to the negative 5 power and y to the negative 7th power. Simplifying, again, anytime you have negative exponents, we can write our answer using a fraction. If we have x to the negative 5, we can move that to the denominator or bottom of the fraction and change it x to the positive 5. Same thing with y to the negative 7. We can move that to the denominator and change it to a positive 7. If there's no other numbers or no terms on top of the fractions, we can always add a 1. So our final answer is 1 over x to the 5th, y to the 7th. And last question for the section, 8 over 2 c to the negative 3 power. Simplifying first, if we have two numbers without exponents, 8 and 2, we can divide each of those. 8 divided by 2 would be 4. And the negative exponent, if the negative again is on the bottom of the fraction or denominator, we'll switch that to the top of the fraction or the numerator, which would be next to the 4. So instead of c to the negative 3, we can change that c to the positive 3. So our final answer would be 4c to the 3rd power, or 4c cubed. Title of the last section today is Evaluating. Exponents. In this section, we'll evaluate exponents given values. The directions: evaluate, when x equals negative 3 and y equals 5. So for the following problems, we'll be able to use the value x equals negative 3 and y equals 5. First question is y to the negative 2 power. Solving this one, we can first plug in the value. If y equals 5, we can change y to the negative 2, plugging a 5 in, which would be 5 to the negative 2 power. Solving from here, anytime we have a negative exponent, we can make a fraction. 5 to the negative 2, we can write in the denominator as 5 to the positive 2, and then we can add a 1 for the numerator. And our final answer, 5 to the 2nd power, or 5 squared, would be 25. So our final answer would be 1 over 25. Second question is y to the 2nd power, x to the negative 3 power. And again, the first step, we can plug in numbers for x and y. Y is equal to 5, so we'll have 5 to the 2nd power, or 5 squared. X is equal to negative 3. It's a good idea to put parentheses around numbers when they're negative, so you can keep them separated. And also to the negative 3 power. Solving from here, 5 to the 2nd power would be 5 times itself 2 times, or 5 times 5. that'd be 25. And negative exponents again, we can make a fraction. The negative 3 we can write for the denominator. And the exponent, negative 3, we'll put for the denominator, but when we change it, it'll change to a positive 3. So our final answer, 25, would stay the same, over negative 3 to the third power would be negative 3 times itself 3 times. Negative 3 times negative 3 would be positive 9, and 9 times a negative 3 would be negative 27. So our final answer would be 25 over negative 27. And last question for the section. 5, x to the third power, y to the negative 1 power. And again, using the same values as before, we can rewrite the question. 5, x is negative 3 to the third power, and y is 5 to the negative 1 power. Simplifying from here, the first 5 does not have an exponent, so it'll stay the same. The next number, negative 3 to the third power, we can multiply that out. Negative 3 times itself 3 times would be negative 27. And 5 to the negative 1 power, the negative exponents again, we can make a fraction for our answer. And the 5 would go to the denominator. And the negative 1 would become positive 1, or you can also leave it off since 5 to the first power would be 5. Solving from here, if you want to, you could multiply 5 times negative 27 and then divide by 5. Or if we want to, we can divide first or cancel the 5s. 5 divided by 5, and we're left with our answer, which is negative 27. Title of the first section today is multiplication. Property. Of exponents. In this section, we'll look at the multiplication property of exponents. The definition or formula for the section: x to the power of a times x to the power of b equals x to the power of a plus b. What this means is if you have x, which could be, again, any number or any variable, to two exponents, when you're multiplying, we'll be adding the exponents a plus b. First question: x to the fourth power times x to the third power. Again, if you have the same variable or same number, we can add the exponents, so our final answer would be x to the seventh power, 4 plus 3. Second question: 2 to the fifth power times 2 to the third power. Again, if you have the same base, the same number being raised to the exponents, that number 2 would stay the same, and the exponents we can add 5 plus 3, which would be 8. If you have 2 to the 8th power, we can actually simplify that. This would be 2 times itself 8 times. If we write that out, it'd be 2 times itself 8 times. Multiplying, 2 times 2 would be 4. And we can multiply each set of 2's, so we get 4's. Multiplying again, 4 times 4 would be 16. And multiplying the other 4s will have 16. So our final answer will have 16 times 16, which if you multiply that out, it's 256. So the final answer, 2 to the 8th power, which is equal to 256. And last question for the section, y to the 5th power times y to the negative 3rd power times x squared. The multiplication property of exponents can only be used when you have the same variable or same numbers. So the y values we can combine. Y to the 5th times y to the negative 3. Adding those together, 5 plus a negative 3 would be 2. And the x squared we cannot combine, but we'll leave it the same in our answer. So our final answer would be y squared times x squared. Title of the last section today is More Simplifying Exponents. In this section, we'll continue to use the property of multiplying exponents. First question is 3r times r to the 4th power. Simplifying this question, if we have a single coefficient 3 and there's no other coefficient or number to multiply by, the 3 would stay the same. R times r to the 4th. If you have a variable without the exponent, you can always add a 1 on there. So r is the same as r to the 1st power. And again, when we're multiplying the same base, the same variables, the exponents we can add. So our final answer would be 3r to the 5th. Second question, in parentheses 15, a to the 3rd power times a second parentheses negative 3a. Multiplying again, the coefficients or numbers in front of the variable we can multiply. 15 times a negative 3. That would be negative 45. And a to the 3rd power times a, or a we can change as a to the 1st. The same variable or same base, we can add the exponents, which would be a to the 4th. So the final answer, negative 45 times a to the 4th. Next question, x to the 5th power times x to the 4th power times x to the 3rd power. In this question, all the bases or variables are the same, so we can add all the exponents for our final answer, which would be x to the exponent of 5 plus 4, which would be 9, plus 3 more would be 12. So x to the 12th power. And last question for the section, 5y to the negative 2nd power times 2y to the negative 5th power. Again, the coefficients or numbers we can multiply first. 5 times 2, which would be 10. And the variable y, we can add the exponents. Negative 2 plus a negative 5, which would be negative 7. Anytime we have negative exponents, we can simplify those, if you remember from previous sections, by writing fractions. So our final answer, 10, would stay the same. Making a fraction, the negative exponent would go to the denominator or bottom of the fraction. So instead of y to the negative 7, we'll have y to the positive 7. So our final answer is 10 over y to the 7th. subtitle of the first section is Review, Multiplication, Property of exponents. In this section, we'll review the multiplication property of exponents, in which you add the exponents together. First question, x to the fifth times x to the eighth. Again, if you have the same base, the same variable, or same number, in this case we have x, would stay the same, and the exponents 5 and 8, we can add those together. So our final answer is x to the 13th. Next question, in parentheses, x squared, y squared. And second parentheses, x to the 6th power times y. Simplifying, we can combine the like bases, or the same variables. The x's, if we combine those, x to the 2nd power times x to the 6th power. We'll add the exponents, which would be x to the 8th power. And the y variable, y squared times y. The y, again, you can add the exponent of 1 if there's no exponent, and 2 plus 1 would give us 3. So our final answer, x to the 8th times y to the 3rd. Next question, x squared, and inside parentheses, x to the negative 5 power, y to the 2nd power. Simplifying again, we can combine the same variables, the x's. If we have x squared times x to the negative 5th, adding 2 plus a negative 5 would give us negative 3. And the y squared, there's only a single y, so y squared or y to the 2nd power would stay the same. Keep in mind, when you have negative exponents, you can continue to simplify. Rewriting this as a fraction, x to the negative 3rd power, we can rewrite that on the bottom or denominator of the fraction, and changing the negative 3 to a positive 3. The y squared, since it's positive, will stay on top of the fraction or the numerator. So our final answer would be y squared over x to the 3rd power. And last question for the section, negative m squared times 4r to the 3rd power times 12r to the negative 4th power times 5m. Simplifying first, we can take the coefficients, the numbers in front of the variables, and multiply those together. If we multiply 4 times 12, that would be 48. And if we multiply 48 times 5, that would give us 240. There is a negative for the first variable, so that negative times 240 would give the coefficient or number negative 240. From there, we can combine the variables. The m squared we can combine with the m, or n to the 1st power. M squared times m to the 1st. Adding exponents would be m to the 3rd power. And combining the r values, we have r to the 3rd power times r to the negative 4th power. Adding 3 plus a negative 4, that would be